Thanks for having me, everybody. I'm Doug Sillars, and I'm going to talk about video streaming and how to video stream and how to keep video from killing your customers' data plans. Really quickly about me, I'm a freelancer. I do developer relations. I worked for AT&T in Redmond for like 10 years. But then I decided to become a digital nomad and travel around Europe with my family, so I've been doing that for 2 years. So I do a lot of performance stuff. I do help people speed up their web apps, their native apps. I wrote a book for O'Reilly on how to speed up your Android app. If you're interested, that's the PDF. I'll post the slides and all that. I do stuff on performance, images, and video, which I'll talk about today. I've been playing around with some AR and some WebXR, which is fun. And then I'm the only Doug Sillars on the internet, so I'm easy to find. So video killed my data plan. And the way I came up with this idea is I was in Europe and I had an Irish SIM and I had the opportunity to go to Moscow for a conference. And I was like, I wonder how much it'll cost to take my SIM to Russia. And it turns out the answer is 10 euros 24 a megabyte. That's like $12 to $14 a megabyte. So we're going to use that sort of number as like when we start looking at video that's on the web. And like when you have to explain to your children why they're eating rice every day for dinner for the month, it's because your cell phone plan went bananas. This is year over year. We see that on mobile and desktop, the amount of video on web pages is growing. I'm adding a 2019, but they changed the infrastructure on the HTTP archive, so it doesn't look like it's growing that much, but it's still growing. When we look at web pages, does anyone know web page test as a tool? A couple hands. So web page test is an awesome tool. And so I was studying web page test, pages with video and pages without video. And if you look, the speed index is it's measured in milliseconds. It's how fast a page loads. And pages with video are about 3 seconds slower because there's video on them. It turns out it's not just because of the video. The pages are just a lot bigger. The median web page with video is 7 megabytes. Only 2.5 megabytes is video, but there's double the CSS, triple the images, and double the JavaScript. So sites that have video tend to have a lot of other crap too. And that causes them to slow down. Interestingly, I probably won't get to this story, but we can talk about it afterwards. These are the different domains that were serving the most video on the web. We see Akamai, we see Google, we see Cloudinary, we see AWS, we see CloudFront. I expected that. I didn't expect to see Facebook at 66% of all of the video files being served. It's a bug. Facebook says it's in Chrome. Chrome says it's in Facebook. We can have that discussion later too. When you look at video quality metrics, the major metrics are, did the video start? Did the video stall while it was playing? And does it look good? And that's what like top analytics companies are looking at. And my contention is if you optimize the video that's being delivered, you work on the performance, you're going to solve all of these issues. This one marketing company came up with this idea of buffer rage, where your customers get really pissed off when a video doesn't load. And there's this really old stat that when a web page is really slow, people throw their phones. And so that's where I got the image, the idea of the image. This is data from Conviva from late last year. And so Conviva is like the top analytics company for video. And this is like based on like 17 billion video plays. And what's really interesting is you see right here, like 3% of videos fail to start. And like between 16 and 27% it would have played, but the customers gave up because it took so long. And like, as web developers, it's like, what if your web page didn't work a quarter of the time? Like, would we still be employed? Probably not, but so this is what video's doing, so we gotta get better at it. So let's first look at this. This is something that I was looking at what was causing this. The HTTP archive has 5 million websites in it. I found 404s and things like that, but not a lot. I think most of it is stuff like this. We're on a web page and it's like, oops, you can't watch that in this country. This doesn't happen as much in the States, but in Europe it happens a lot. This is CBS. I was in Europe and I got this oops message, and what's worse is it took 231 requests and 3.1 megabytes to tell me oops. Right? That's horrible. And actually Amazon does this really well. So I've got a Prime account, and when I fire up Prime Video in Europe, it's like, you're traveling here's some stuff that you can watch when you get back to the States. And here's the stuff you can watch while you're traveling. But that's great, because I don't have to click the button and get an oops, which is super disappointing. If they tell me right up, like, that stuff that's in the press, we can't watch it while you're in Latvia, but you can watch it when you get back to the States. That's, at least it's an error message that I understand. But this is the one that blows my mind. Like 16% on mobile, but their data is saying that 28% of videos on desktop people just give up. And the reason is, if you look at the startup time, the average startup time is 6 seconds for a video to start up on desktop. And if something takes 6 seconds, people start giving up. And Akamai has some data on that. They found that everyone hangs out for 2 seconds when they hit play. And then after 2 seconds, you lose 6% of your audience every additional second. So if your video takes 6 seconds slow, you're losing, a lot of your audience. It depends on the type of video. If it's a short video, people give up a lot faster. So if you are watching a video of a cat dressed up like a shark, sitting on a Roomba, chasing a duck, after about 4 seconds, you're questioning your life, right? And you move on. But if you're gonna sit down and watch a movie or a TV show, you're already dedicating like 20, 40 minutes. You're gonna hang out for a little longer. I also found that on the web, 19% of websites are serving the identical video on desktop and on mobile. So that means either they're serving a video that starts up really fast on desktop and mobile, or they're serving a really, really big video that looks great on both but takes forever to start up on mobile. It's mostly number 3. So, like, I talk about image optimization, and if you look at websites in general, it's kind of hard to see on this graph, but we're serving less data to mobile devices than we are to desktop devices. On video, we're not doing nearly as well. The first thing to do is watch that y-axis. Oh yeah, it's 10 times bigger because we're adding video. And we're serving, you can't really see it, but we're actually serving more video, we're serving more kilobytes of video to mobile devices than we are to the desktop. And that's backwards, we shouldn't do that. So what are people doing? This is MLB.com, and it's the same video on both desktop and on mobile. It's a playback of a video of a baseball game, so it's 17 megabytes, it's 83 seconds. And so I thought, well, I could optimize this, so I downscaled it. I uploaded it to Cloudinary just to optimize the video really easily, and lowered the audio quality, and it became 13 megabytes. And then I resized it to a smaller size for mobile, so it was only 6 megabytes, right? This is a way to make it download faster on these different devices. I found a web page. This is from Web Page Test, so it gives you a graph of like what's being downloaded, and there's 267 kilobytes of video on the desktop and double that on mobile. And so what was happening here is the mobile device's retina. So it's serving the 2x WebM as opposed to just the WebM. For your CSS buffs, they hide the video on mobile, so they download 500 kilobytes and then they hide it with the CSS. So you never actually see the video. Like, don't do that. Like, if the video's not going to show up, don't show it. On the web, there's different attributes to the video tag. You can hit preload equals auto. And what that does is the browser automatically downloads all of the chunks of the video, whether you press play or not. So that's what's happening here, is this is the video downloading. So you're on your mobile device and you see the video and you're like, I don't really want to watch that video. Well, it got downloaded against your plan anyway on a page like this. And then in this web page, it ended up being 23.6 megabytes of data. So that's, in Russia, 236 euros, right, for one web page. You should only do this if you're really sure they're going to watch the movie. Like if it's Amazon Prime, if it's Netflix, if you know they're going to watch the video, this is great. But if you're not sure, probably not a great idea. This is McLaren. This is their German version of their website. And I wanted to see if they were still doing this. And so they're doing preload equals auto for a bunch of MP4 videos. And I just loaded the web page. And you can see in DevTools when I search for MP4, oh, I lost it. Oh, crap, it's on the other screen. So let's see if I can, there we go, look at that. All right, you can see down here, these are all the MP4s that just loaded. What I did is, and now I'm doing the funky thing like this. All right, so I clicked one of them. This is the video. I'll just, if I hit space, right? Has nothing to do with cars. Absolutely nothing to do with cars. The other interesting thing is that's it. on the web page. It's not animated, but they're downloading it, and it was 19.1 megabytes that downloaded, preload equals auto, mobile view, right? Like, this is bananas. We shouldn't be doing stuff like that. Now I'll bring my mouse back. Here we go. Mouse is back over here. All right, so you can also do things like you can actually tell in the browser, you can use link, you can do preloads, which tells the browser load this at a higher priority than anything else. This web page is actually loading the video at a higher priority than the homepage.js. Don't do that, that's really bad. They don't do that on mobile, they only do that on the desktop. But it's still really bad, don't do that. The default in Chrome and Safari is preload equals metadata, and that only downloads the first X% of a video. The problem is this web page has a giant video, so I don't know if you can see it, it's way down at the bottom, but there's this giant, that's the video downloading, and I call that the mobile middle finger on the waterfall, because in this case, there's one request, and it was 2.7 megabytes for a video. And you might think, well, it was probably a really important video. It was 150 seconds long, it's 1080p, and it's 97 megabytes. So let's look at this web page to see where it is. You know, this is the mobile version. This is like the first 7 views, and you keep scrolling, and you keep scrolling. The video was way down here, like the 15th or 16th viewport on this mobile, right? And it's 42% of the data being downloaded. You should really be careful about this. If you don't think they're ever going to watch the video, you should use preload equals none, because preload equals none downloads none of it. Another big thing that's happening in video these days is background videos, and so like this is a place where you might want to take your kids to play because it's got all this cool stuff. It's really, I mean, that sort of draws you in, right? The background video. This video file was 5.3 megabytes, but 5% of the file was the audio track that nobody hears. You should remove the audio track for silent videos because that'll make it smaller, it'll download faster. And if you don't want me to find things, you should just name it background.mp4. On this webpage it's called Steven.mp4. I'm like, Steven, I don't know what's going on here. And I looked at it and I'm like, oh, there's audio, what the heck are they doing? So remove the audio. You actually have to remove the stream from it, so you can't actually mute the stream because the video player will add an empty stream that still takes up kilobytes. They also download that video on mobile, but they hide it. And then they have a fallback JPEG that they also hide. That fallback JPEG is 900K that they hide. Yeah, all right, so here's another one. This is a web page that has a background video that you will see if you hang out at the top of the page for a really long time. So let's look at the video that's here. The first thing we learned is that Bob Ross is also a photographer. It's 33 megabytes, it's 27 seconds long. Who sits at the top of a web page for 27 seconds to watch the video? Show of hands? Yeah, that's what I thought. It's 2500 by 1200 pixels, right? And it's 10 megabits per second. So you should really resize your video to a reasonable size. Renaming it 720p does not re-encode the video to 720p. I don't like making fun of people, but sometimes it's just too easy. All right, so you could resize it. I resized it, 1080p became 8 megabytes, 720p, 4.3 megabytes. It's big, but it's not 33 megabytes. We're getting to something that's reasonable. It downloads on mobile. In this case, Chrome gave up after 17 megabytes, so I paid 170 euros in Russia, but I never actually saw the video. And I keep joking about how video isn't cheap. It's not cheap for us as customers, but it's also not cheap for us as developers. So this is Garth Brooks' webpage, and this should be playing. Maybe it's the next click that makes it play. Yeah, all right, so this was his webpage earlier this year. And I've got one of those Chrome extensions that lets me speed up the video. If you look really carefully, there's another video playing behind it. There's a background video playing behind the video. And so this video, there's the video of Garth Brooks singing, which is 51 megabytes. We've got the background video, which is 7 megabytes. There's an animated GIF, Pre-Order 2. He's got a new album coming out, I guess, which is 6 megabytes. All of this stuff is being served out of S3, and S3 is really awesome, but you should be like using a CDN or something because they charge you 9 cents a gigabyte, and when you're serving 70 megabytes per page load out of S3, that's half a penny on every single page load. That's ridiculous. You shouldn't do that. Probably the Amazon people are saying, yeah, you should do that because and then to throw into that, there's a bug in Chrome where if you have a large video that loops, it isn't cached. You can see who filed that bug. So I left the Garth Brooks webpage open for a while, and it downloaded the Notre Dame video 5 times. That's like 2.5 cents that I cost Garth Brooks by keeping the webpage open for 20 minutes, right? You gotta be careful about this stuff, right? So is the solution streaming video? Like you can use YouTube or Vimeo, but expect there's no initial video download, but YouTube or Vimeo is gonna cost you like a megabyte of like stuff, right? So this was a web page that I built that just has a YouTube file on it. And this is all the JavaScript, the fonts, and everything that downloaded before the video plays, right? There's a 1 megabyte hit that you take for that. So you can serve your own video streaming. And so how does video streaming work? There's a manifest file that lists all the different streams, like the different bit rates. The player chooses a stream. It starts downloading the segments. Each segment's like 5 seconds long. Sometimes it's 2, sometimes it's 10. It depends on how you build it. The segments start going into the buffer, and then the video should play. As the video starts playing, the player can start estimating the network throughput and then get you the optimal bit rate. And so you've seen this, like when you start watching a video and it looks like crap for like the first 2 seconds, it's really pixelated, and then it sharpens right away. They're starting at a really low bit rate. A really low bit rate, very low data. It starts very quickly, and then it can optimize as time goes on. So this is what a manifest file looks like. This is HLS. This is from a TED Talk. And so let's just look at TED Talks have subtitles in a lot of different languages. That's what I learned from looking at this. So what does the video section look like? Each stream has 2 lines, right? So it tells you the bandwidth, it tells you the codecs and the resolution, and then it tells the player where to find those files. And the player always starts with the first stream. And so in this case, it's going to start with 1.4 megabits per second. If the stream is too high, I found a web page in Argentina that starts at 37 megabits per second. That doesn't play anywhere. It starts downloading the segments, but it takes a long time to fill up the buffer. The video doesn't play, and then the player has to change the bit rate. And then it lowers the bit rate, and it starts playing. But we just added this long latency for the video starting up. So we want to start at a low bit rate. Video players, by default, are focused on bandwidth, not on the video size. So what I did is I built a video playing this TED Talk, and I said, hey, I'm gonna make the width 720 pixels, and then I'll make the width 360 pixels. And if you look, HLS.js downloads the same amount of video no matter what size the screen is. It's based on the network speed. Video.js actually downloads less, right? So at 8.4 to 2.7. So you should be careful because it might download way more video than it needs to, unless you add the responsive parameters, which are not on by default. So they all have responsive attributes, but they're not on by default. So you should look through the APIs to turn them on. And when I turn on the responsive attribute for HLS.js, it goes from 13.9 to 4.1 megabytes. So it's serving the right size video. We're not wasting pixels. It just shows up on the screen. I think a lot of this has to do with what causes a long time for video startup. So if you start off with a really low bit rate, it starts up really, really quickly, and then the player quickly jumps to a good bit rate. If you start off with a really high bit rate, it can't play, it goes to that low bit rate, and then goes to that optimal bit rate. We've added a step, that's taking time. This is what Amazon does. Amazon actually starts right here in the middle. It's sort of the Goldilocks approach, like it's a higher quality video, it takes a couple seconds longer to play, but because it's a longer play, right, people hang out longer for a 20, 40 minute long video, people will wait and they'll see it's really sharp from the very beginning on Amazon, which is really cool. So if I look at a timeline of this, The lowest quality video starts at 11 seconds on my mobile device. The Amazon version starts here at like 13 or 14 seconds, but it's much higher quality than that. So these are two good approaches. It depends on sort of how you want to build your video streaming. If you start with a really high bit rate, it takes a lot longer for the video to start. And what's really interesting is this video quality and that video quality are identical. It just took 6 seconds longer for it to happen. So this is walking through how that works. So just a quick case study with a manifest file. This is the TED Talk, and these are the order of the bit rates. You start here, and then you get lower, higher, higher, higher. I was testing this on a 3G connection with web page test, and I found that it starts at the high bit rate and then drops to the lowest quality bit rate all the way through. And so you know how on a TED Talk there's like that intro with like the TED Talk sound? That's these first 3 segments, and then that's the TED Talk. Like you can actually see how they're building it, which is kind of fun. But it's playing at really low quality, and you could tell that the quality was really low. And so what I noticed is the bit rate is 1.4 megabits per second, but they're downloading 600 kilobit per second video. Why are they doing that? The buffer fills up twice as fast. It's never going to stall, right? So they're filling up the buffer twice as fast. However, it lowers the quality. So what I did is I set the bandwidth to 600. 600. This is going to stall a lot more often, but I might be improving the quality. Obviously, there's 2 ends of that spectrum. There's a sweet spot in the middle. So what happened when I did that? First thing you notice is the y-axis gets lower, right? Because it's not 1.5 megabits per second. It's now starting at 600. And what happened is it initially drops to really low quality, but it quickly recovers to the good quality video. Right? So but why does it drop and then jump back? And I was trying to figure that out. So I started looking at each segment, and there's a manifest file that lists each segment. And the first segment is 5 seconds long, and it's 900 kilobytes. The second segment is 6.8 seconds long, and it's 100 kilobytes. This math doesn't work, right? If it's 7 seconds long, it should probably be larger than the first segment. So they've got some sort of error in the way they're denoting their segments here. And I played around with the math, and I did a lot of experiments, and I couldn't get it to work. So I just downloaded the whole intro in one 12-second download. And when I did that, the video quality remained high through the entire playback. It actually got better. So there are ways you can play with video streaming to improve the quality, to reduce the number of stalls. There's a sweet spot in the middle. There's the Spangler Effect. And so you know this, you guys know the movie, do you know the scene? I don't know if it'll play the audio. I have my audio turned down. In this scene, he warns all of the Ghostbusters to never cross the streams. And the reason you don't cross the streams is total protonic reversal. You should not have a web page that plays 2 streams at the same time, because it's trying to maximize the data coming through the pipe. And if you have 2 of them, you're going to get half the quality for both of them. And just to prove that the internet is the internet, I found a web page with 24 simultaneous streams on mobile. Don't do this. On Wi-Fi, I couldn't get it to work. I had to wait until 2 in the morning when all my neighbors went to sleep, right? So I had more throughput. 245 megabytes in 4 minutes. Each one of these things is a stream. And you could see not all of them loaded because it still didn't work. So you shouldn't do that. I don't really have time to talk about the Facebook one, but video files are big, and so we should think about that before we put them up on the website. So you should resize your videos for quality, bit rate, dimensions. If the video's gonna be hidden, don't download it. Avoid preload equals auto. If it's silent, don't download audio. Start at a lower bit rate for faster startup. The Amazon approach, middle bit rate for better quality. 1 video at a time, please. And then if you're using a third party, you should audit it for performance. And you should really respect your users' data plans. So with that, I'd be happy to take any questions.
What do you recommend if I have the need to show 15 videos simultaneously, actually in VR?
In VR, get them as small as possible. And so I was talking to a guy who was building he was trying to do 4K video in A-frame and on the desktop. And so then the problem is now you're like distorting the screen while it's trying to play 4K video, right? And you're having a lot of performance problems. So I was telling him to like reduce if it's a screen inside a screen, you don't need it to be 4K. It can be a lot lower quality and it'll still look awesome.
But streaming's still a no-no, yeah?
I think streaming would be, just know that if you're streaming 12 of them, it's going to be lower, they're all going to be lower quality.
Yeah.
Just be aware of that. In this case, those were really high, those were all trying to stream like 600 kilobits per second times whatever that number, like 12 or 24, and it just didn't work. If it works, that's great. But remember, may have people on a mobile phone. You don't. If you don't have people on a mobile phone,
No, they use Texas.
It's not your use case, then yeah, I wouldn't. Yeah.
Do you find any interesting effects when jumping through the stream if you're clicking, like skip 15 seconds and then go back, or do you do any of that?
In terms of what happens when the video player is doing that? It depends if it's in the buffer or not, right? So if it's got 20 seconds in the buffer and you flip ahead 15 seconds, it'll play immediately. Otherwise, it has to skip ahead. But it knows all the segments, right? Because it has the math as to where that is, so it can immediately start requesting those new segments. So generally, you need 1 or 2 segments to start playback. So it just depends how fast your connection is for that to happen. Yeah.
Piggybacking that, does it then start the same process over? Like start at a middle rate or start low, start high?
No, because at that point, it knows the speed of your network. Assuming that your network connection is fairly stable, like I'm assuming you're in one place, not in a car or on a train or something. But if it knows if the player knows the speed and you switch to a different part of the video, it knows the speed, so it starts at that bit rate. When you're looping videos, interestingly, some of the players still keep the low quality for the first 5 seconds. So it'll be low quality, really high quality, low quality, really high quality, low quality. Other players download the first 5 seconds every time the player goes through. So it plays the whole video, downloads the first 5 seconds, plays the rest of the video cached, downloads the first second. There's some really interesting characteristics, and you should really audit how the player works depending on what your use case is. Yeah?
Still sort of on the same question. If a video is below the fold,
Yes.
Is there a way to figure out the network speed and optimize before you go under the fold to start the video?
The players may have that option. You'd have to look at what capabilities are available, but it's possible that might be. I don't know off the top of my head. Yeah?
Can you modify the manifest file, the streaming manifest file, without actually downloading the video?
Yes. So are you thinking like you could have a different manifest file for mobile than you could have for desktop? Yeah, very much so. And so the way I did that TED Talk thing is I stole their manifest file and hosted it on my own server and still pointed to their files so that I wasn't hosting all of the video. I was just requesting it based on my manifest file. It's not that bad, is it? It was for testing purposes.
Sure.